The production of pulses and their per capita requirement for consumption are not in harmony. Although the production is increased to some extent, the total per capita availability is reduced to 65% due to the constant population inflation. The simultaneous approach to the problem can be minimization of losses during milling. On an average, 10 to 15% losses are observed in milling process through brokens and powder. Villagers used floor mills for dehulling of pulses after a prolonged treatment where dal recovery seldom exceeds 58%. To the contrary, in commercial mills, higher recovery to the tune of 68 to 70% is obtained, but the total investment is beyond the capacity of an average person. So, it was need of a day to develop dal mill with low investment, having high recovery and suitable for cottage level industry. Secondly, farmers produce pulses and sell it at low price to the middleman. They do not have processing facilities at rural level to process the farm produce. Moreover, transportation of raw material to commercial mills and back to the consumer, mostly staying in villages, add extra burden to the producer. If pulses are processed at rural level, the villagers may get the finished product at comparatively low prices. Similarly, it can save transportation and handling losses to an extent of 3.7% in order to overcome the problems, and with the view that farmers should become processor. PKV Mini Dal Mill is developed by All India Coordinated Research Project on Post-Harvest Engineering and Technology, Dr. Punjabrao Deshmukh Krishi Vidyapeeth, Akola. The PKV Mini Dal Mill consists of dehulling unit, sieve unit, screw conveyor, aspirator, cyclone separator and splitter. The hopper is provided for feeding the grain lot. The horizontal cone type abrasive roller is provided for dehulling of grain with provision of inlet and outlet control valves. The sieve unit is provided for separation of whole grains, dal and brokens. Oil water tank and screw conveyor is provided for oil and water application. Splitter is provided for splitting dehusked whole grains, that is gota. Aspirator and cyclone separator is provided for separation of husk and powder. The PKV Mini Dal Mill can be used for cleaning and grading of any grains by using proper sieve in sieve unit. At present, pigeon pea grains are being used for cleaning and grading. The uncleaned pigeon pea grains are fed in the secondary hopper. The grains are allowed to fall on the sieve unit by opening the inlet flap. Before reaching the grains to the sieve, aspirator sucks the lighter impurities and are collected through cyclone separator. The grains roll on the vibrating screen. The cleaned whole grains pass through the screw conveyor and collected through the left outlet. The splits, if any, are collected through the middle outlet, and the brokens, if any, are collected to the bottom and right outlet. Thus, PKV Mini Dal Mill can be used for cleaning and grading of any type of food grains by using proper size sieve. Separate provision for oil treatment is given in the machine. A tank for oil is filled before the start of first pass. The cleaned, graded and dried pigeon pea grains are fed to the hopper. The feed rate is controlled by separate feed control valve and the grains are passed through the abrasive roller with about 150 kg per hour feed rate for scarification. After sufficient scarification in dehulling unit, the scratched grains are then allowed to pass over the sieve unit by using release valve. The scarified whole grains are diverted to screw conveyor. Where oil is applied at the rate of 125 to 150 grams per quintal. This is the first pass for scarification or scorching of grains. In this pass, we get scarified and oil-treated whole grains, negligible dal with and without husk, and brokens in separate outlet. The powder and husk is collected through cyclone separator and thus the operation is dust free. These are the samples showing clear difference between untreated and oil treated grains after first pass. The screen is tapped to remove blocked grains. The oil-treated pigeon pea grains after first pass are then heaped. And covered with plastic gunny bags for 8 to 10 hours. The overnight heaped pigeon pea grains are then spread on tarpaulin for drying for 6 to 8 hours. The dried pigeon pea grains are then collected in the container. These pre-treated and dried pigeon pea grains are fed to the hopper. The feed control valve, that is inlet valve, is opened for passing the grains through the abrasive roller. The release valve, that is outlet valve, is then opened. The mixture of the whole grains, split, broken, are then allowed to pass over sieve unit by opening the outlet valve. The husk in this mixture is sucked by an aspirator and passed to the cyclone separator. In sieve unit, the whole grains are diverted to screw conveyor and the cork of oil tank is opened so that edible oil is applied at the rate of 125 to 150 grams per quintal, and the treated whole grains are collected through the separate outlet. The splits with or without husk are collected through middle outlet and the brokens are collected through the bottom outlet. Thus, treated whole grains, splits and brokens are separated mechanically. Separate outlet is given just below the abrasive roller for separation of powder. The husk from the mixture of grain falling on the sieve unit is sucked by aspirator and comes out through the cyclone separator. This is second pass. In this pass, we get oil treated whole grains with and without husk, some dal with and without husk, broken, powder and husk separately. The oil treated pigeon pea grains after second pass are then heaped. And covered with gunny bags for 8 to 10 hours. The overnight heap samples are then spread on the tarpaulin for drying for 6 to 8 hours. Before third pass, the tank is filled with water for water treatment to completely dehusk grains, locally called as gota. The dried pigeon pea grains are then collected in the container. These pre-treated and dried pigeon pea grains are fed to the hopper. The feed control valve is opened for passing the grains through the abrasive roller. The release valve is then opened. The mixture of whole grains, split, broken are then allowed to pass over the sieve unit by opening the outlet valve. The husk in this mixture is sucked by the aspirator and passed to the cyclone separator. Here, the grains are retained with abrasive roller for sufficient time so that maximum completely dehulled whole grains come out through the outlet. Here we can observe maximum completely dehulled grains, locally called as gota, coming out through the outlet. In sieve unit, the dehulled whole grains are diverted to the screw conveyor and the cork of the water tank is opened so that water is applied at the rate of 8 to 10 liters per quintal. And the water treated whole grains are collected through separate outlet. During this third pass, splits with or without husk are collected through middle outlet and the brokens are collected through bottom outlet.